Hello everyone, today I'm going to explain a semi-niche algorithm called Manacher's algorithm. And this algorithm can be used to find the longest palindrome in a string, the number of palindromes of a certain length in a string, and so on and so forth. And is also just a good introductory string algorithm. Because it's quite simple and it can help you understand some of the other ones that are more difficult as well. But anyway, let's get started. So, the aim of this algorithm is to calculate the length of the longest palindrome centered around each character. And instead of the actual length, for coding reasons, we aren't going to store the actual length. Instead, we're just going to store how far out the boundary of the palindrome is from the center. So, for example, in the output array around this B, we see that the longest palindrome centered around this B is the CBC palindrome that's right here. And we're going to store a number which is how far out is the border of the palindrome. So if we imagine like the border, we see that it stretches kind of 2 out in either direction. And so we're going to have this number here be 2. And I will fill in the rest of the numbers to aid your understanding. So this is 1, 2, 3, 4, 5. So this one should be 5. 1, 2, 1, 1. So we want to get this array here, let's call it len. From the algorithm. So first, let's talk about how you might do this very slowly, and then I'll add in the just one simple kind of if condition to actually make it linear time. So naive algorithm would be if you're starting at index I, you initialize length I to be 1, then you consider expanding the length by +1 and making sure that the palindrome does not break. So the way we do this is by checking that I minus len I is equal to I plus len I on the string. So remember that the number that we have stored here is where the border of the palindrome is. It's going to store the next character, how far away the next character on either side of the palindrome is. So all we would need for this is just a while loop that says while we can expand the palindrome outwards by 1 by looking at the border characters and making sure that they're equal, then do expand. In the worst case, we're doing about n squared expansions. And a very simple example of that is if we had A, or just the same character repeated over and over again. And I'll just quickly do a short example. So let's say we're trying to figure out what len I is of this. So we'll start with 1. And if we start with length I of 1, then the border characters are these two. And we see that they're equal, so we're going to increment it to make it 2. And then, once again, we check the border characters, which are now 2 away from the center, and check if they're equal, and they are equal, so we make it 3. And at the point that the border characters are either outside the string or no longer equal, that's when you just stop increasing it. So you can just use a while loop for that. Okay, so obviously that can run in a time proportional to n squared if you have the same character repeated many times. So let's think about how we can optimize this. So what I'll do is I'll just take this. Let's take this string from earlier and put it down here. So let's say at some stage in that algorithm we've calculated the first all the previous len I values before the one that we're about to calculate. So let's say we've got all of these. And now let's calculate what len I of this is. So all we do is, let's consider the palindrome that reaches furthest to the right of the string. In this case, the palindrome centered at D is the farthest reaching one. And let's have a look at the characters which it envelops. If we store the index of the center character of the largest palindrome we've seen so far, that goes, sorry, not the largest, but the one that goes furthest to the right, then we know that this larger palindrome actually contains the same sequence of letters on the left and right, albeit reversed. So therefore, we already know some information about what's around this character that we're now looking at on the right hand side, based on the numbers that we've already calculated on the left hand side. Each character on the right hand side will have a corresponding character on the other side by kind of flipping it in this mirror centered at the previous palindrome. So, for example, this B has a mirror that's this other B on the other side of the D. And we can see that actually the characters around this B are the same as the characters around this B, but reversed. So around this B we have A, C, B, C, D, and around the other B we have D, C, B, C, A. And we know that the length of the palindrome on the right hand side is definitely equal to at least 2 in this case, because the entire palindrome on the left is contained within this larger palindrome, and therefore all the characters that are around B on this side must be the same on the other side. So straight away we can already initialize len I to be equal to len j, where j is equal to the mirror image of I. This is the first case that we're in right now. And then after assigning this, we will run the while loop from before, just in case, as I'll give an example later, there might actually be more characters outside of the larger palindrome which are not the same on both sides. Okay, so let's consider another case where that is actually true. So let's take this again. Did not mean to press that. So now, let's say on this side, we actually have a D here. And we've calculated all these values on the left half. And that one. And now, we're trying to calculate the value of len I for this character B. Let's find the furthest right reaching palindrome again, and it's now this, not including this left and right character anymore because now they're different. So same as before, let's find the mirror, transfer over the length I of the opposite side, and I wrote them the wrong way around, so that's meant to be I. Okay, so we transfer over that. Now we can see that because this palindrome CBC is actually at the border of the larger palindrome, there's actually some additional information on the outer edges of it that we haven't captured yet. And as we can see, the length of this palindrome isn't 2, it's actually 3, because we can expand it 1 further out, whereas we couldn't on the left hand side. And therefore, after we do this assignment, we should run the same while loop from before, because this might lead to an expansion of the palindrome. And there's only one thing to consider here, which is the opposite of the information here. Let's say that instead of the right character becoming a D, this left character was a D instead. And now we can see that if we were to transfer over the length of the palindrome from the right hand side, we'd actually be wrong. So if we did this, length I is equal to len j, we'd copy over the fact that the palindrome here is of length 3. Whereas actually, the palindrome over here is of length 2. And the reason why we got this wrong is because this outer character here that's on the palindrome on the mirror image is actually not inside the borders of the larger palindrome. And therefore we've actually assumed some incorrect information. So in fact, we can't do this assignment. Instead, we'll assign the length of I to however far the border is from this index, because we know that we're at least that long, and then we can, just in case, let's say this actually this might actually expand the palindrome, we can then run the while loop again just to make sure. But in this case, we're going to just assign it to the border. And that's pretty much it for how the algorithm works. And now let's explain how to code it. And while I'm coding it, I can easily prove why it runs a linear time. Okay, so let's head over to VS Code. And I've set up these cases here already for us to test the program. So let's take in the length of the string and the string itself. And let's initialize the length vector. And now we need to maintain the length, or not the length, but how far to the right does the rightmost palindrome expand to, and where is it centered at. So similarly to how we're defining len I, we're going to define the how far the palindrome reaches by a pointer r, which is the next character past the border of the palindrome, and C, which is the center of the palindrome. So let's initialize C to be some bogus value and R to be another bogus value. And let's now iterate through. All we need to do now is check, are we within the border of the palindrome? Now, how do we calculate the index j of the mirror? Well, what we need to do is we need to see how many characters to the right of the center are we, and then go that same distance on the other side. And the distance to the center will be I minus C, and then we need to go that many characters backwards from C, so we can do C minus I minus C, which is just 2C minus I, and that's how we can calculate what j is. So let's go over here and write int j is 2 times C minus I. And this mirror image is always guaranteed to exist if we're within the palindrome, because otherwise the palindrome wouldn't exist, because there has to be an equal character on either side of the center. And now we can initialize len I to the minimum of whatever len j is, which is the mirror image, or the distance to the border of the palindrome, because remember, this is all the information we have, it's just what's contained within the larger palindrome. So we can only go at most to the border. Okay, now we need to run the algorithm to expand the palindrome out as far as possible. So in this case, all we need to do is check whether the character on either side of the border are equal to each other. In that case, we can expand the length by 1. And before we do this, let's just make sure that our indices are in the bounds of the array by adding these conditions here. Okay, now let's take a quick break from the code. We're not finished quite yet. We still need to update the R and C values to find, just to check whether the palindrome is bigger than the right reaching palindrome is further than before. But before we do that, let's prove why the algorithm works. So the way we're going to improve the runtime of the algorithm is by considering how many times are we running that while loop that we have. Because before, that while loop that we have is running up to n squared times, or O of n squared times. But in Manacher's algorithm, we can show that it actually only runs a linear number of times. So in the first case, we're assigning the length of the palindrome on one side to the length of the other one. And this is the case where the palindrome is entirely contained within the larger palindrome. Then we know that the next character differs, and the while loop will therefore only run one time. So that's one case. The while loop will run one time just to find that the characters on either side of the palindrome are incorrect, mismatched, and then it'll break. So that's the first case. The second case is when the palindrome we have is actually expanding past the border. And in this case, we know that when we assign the length is going to straight away be outside of the border of the palindrome. And here's the interesting thing: if the while loop ends up updating the length of the palindrome, in this case, the right pointer will also increase by 1 for the next iteration, because now the furthest reaching palindrome will end further than it did before. In this case here, when we have the palindrome and we kind of cut it off at the right endpoint, we know that we're not gonna be able to expand outwards. In any case, the right pointer only moves. The while loop only iterates if the right pointer moves. So in fact, we don't even need an if condition. We can just increase R in this loop, and we can update the center to the current position. The only change I'm going to make is initializing R to 0, because we need to say that the border of R is currently at the first character, because when we increment it, it will then push it to the right place to begin with. And that's actually the entire algorithm. So now, let's just print out the length array to double check that my code is not incorrect. Okay, so let's run this code. So let's just put in this input that I've prepared. We get the correct result. What was that? I don't use Java, I promise. That one also gives the correct result. Okay, good. So now we have this algorithm working, and I've shown why it works, why it's linear time. The next thing to do is actually, how do you use this algorithm to find the longest length palindrome? So let's return to this example. Okay, so let's get the length array back. So this is 1, 2, 3. 1, 1, 2, 3, 4. That's 4. 1, and then that's going to be the mirror image. I'm using the algorithm to find the table myself. We're now trying to find the longest length palindrome in the entire string. So, I mean, the obvious thing to do is just take the highest number in the length array, and we now have this palindrome here, whose length is equal to 1, 2, 3, 4, 5, 6, 7. And you can calculate the length of this palindrome by just doubling the length I and then minusing 1. To find this palindrome, and that works if the longest palindrome length is odd, because this algorithm, remember, only checks for palindromes which are centered around a certain character. Some palindromes don't have a center, I mean, the most basic example is just ABBA. This is a palindrome, but the center is somewhere in between the two sides. So wouldn't it be convenient if we just calculated len I from every position, including in between the characters? And there's a very easy way to do that. All we do is we put some bogus character like a hashtag to kind of bloat up the string. And now we have something like this. So now we see actually, and that's because if this was an odd length palindrome, its length would be like 2 times len I minus 1. But we actually we have x of these spaces being hashtags and x minus 1 of these spaces not being hashtags, and therefore x minus 1 is that x is len I and x minus 1 is len I minus 1, and x minus 1 is how many characters that are not hashtags are in your palindrome. And the same condition actually works for the odd length palindromes as well. So like let's say if this was the longest palindrome, the length would be 2 minus 1, which is... So now let's use this idea to solve CSES longest palindrome, and I have like 4 wrong submissions because I was coding Manacher's algorithm wrong before, because I was the silly goose. Okay, so now let's implement this algorithm better. So how do you actually format the string? Okay, so in CSES it doesn't actually give you the length, you just have to calculate it. So I'm just gonna move this down and then just assign it to s.size. But I'm not gonna do that actually. I'm gonna make a string t which has the hashtags in it. And I'm gonna initialize it to a hashtag, and then for every character in s, I'm just gonna add the character and then add a hashtag after it. And that's gonna create our new string, and then I'm gonna assign n to the length of that hashtagged string. I literally just run the exact same algorithm as before, but I replaced s with t. And now I just go through all the len i's, and I just find the maximum out of all of them, minus 1 of course, and then print out the answer. So if I put in that, it gives me 3, and actually on CSES they want the palindrome itself, not just the length. So all I'll do here is I'll also store the starting position of my palindrome, and I'll say that, well, first let's calculate the length of the palindrome, and then if it's more than the current best answer, we assign the answer there to L, and we set the center of the palindrome to our current position divided by 2, because we need to, for every character we've passed, we've also passed the hashtag. So we need to divide the index by 2 to get the true index in the original string s. Now for our answer, we can just use the original string s to get that, recover the palindrome. So now if I run this code again and plop this string right in here, we get ABT. So what have I done wrong here? So I guess what I've done is that my index is actually off by 1. So can I think of why that is? So if I have hashtag A, hashtag Y, hashtag B, hashtag A, hashtag B, of course, because this pos is actually the center of the palindrome, it's not the start position of the palindrome. So to get the center of the palindrome, I first need to subtract the length from it to shift this back in t to the start position, and then divide by 2. So let's compile and run again, and plop the same string in, we get bab. Okay, now just to double check, I'll do the same thing, but it would be AAB, because now the longest palindrome is 4 long. And we get a runtime error. Oh, of course, look at what I've done. I've checked that I is less than or equal to r instead of saying that I is strictly less than r, because this, if it's equal to r, then it's on the boundary outside of the mirror, so it's not actually contained within the palindrome. So it was just pure luck that it worked all this time. So that's quite unfortunate. Let's just run it again and we get B8AB this time. Okay, cool. So now let's submit this code to CSES and pray that it works and doesn't jumble it on some random test case. So let's head over to the strings directory and submit this and see if it works. Oh, look at that, accepted, thank goodness. Highest runtime 0.04 seconds. Let's look at the top code. I don't know how this guy does it. He just does everything faster than me. I don't know how. But anyway, that's the explanation finished. So that's a very simple algorithm. And next time I'll go over the Z algorithm, which actually is extremely similar to this one. It uses the same principle of taking a naive algorithm, which uses kind of a while loop, then keeping track of the furthest right reaching kind of structure, and then abusing some kind of symmetry in the structure to push the algorithm to either a place where it cannot expand more or to the border of the box, and then expand the pointer and move the pointer at most n times. So it's very nice, but hopefully you found this video informative, and hopefully I'll be posting a Minecraft video soon as well. So thank you for watching.